Good afternoon, everybody. How's everyone doing today? Good? I'm glad to hear it. So, my name is Ali Alabas. I am a PM on the Microsoft Edge team. And yesterday, I was on my way to getting here, and I realized I was going to be late, so I needed to get an Uber. I'm sure you guys have all had this experience before. Unfortunately, I didn't have my phone with me. It was back at home. And so I had my Surface Pro with LTE. Unfortunately, I was getting less than LTE. I was getting 2G. So that was a problem. And normally what you would do is you would go to the Microsoft Store and download the Uber app, right? Have you ever tried downloading more than 100 megabytes on 2G? Please, has anyone done it before? All right, we got one person. You are a brave soul. Please don't try it. I mean, I'm still trying to recover from the last experience. I will say, though, that I remembered at that point that Uber had a PWA at m.uber.com that I was able to use. And so I immediately went over there and booked my trip over here. And in that moment, on that Uber ride over here, I realized that this problem of network connectivity issues is not unique to me. Every day, hundreds of millions of people all around the world are running into network connectivity issues in some form or another. If you head on over to pwastats.com, a community-driven list of statistics for PWAs, you'll see that there are many, many companies working hard in investing in PWAs so that they can not only improve their customers' experience, but also expand their opportunities on the web. Perhaps Uber wouldn't have made their cut from my ride on over here if I wasn't able to use m.uber.com. But more importantly, I had a way of actually fulfilling that use case because they had that PWA that they optimized for 2G connections. And of course, there are other examples of this. For instance, Grand Velas, Riviera Maya, back in Black Friday, increased their conversion rates more than 50%. More than 50% due to the benefits of PWAs and their features. Specifically, push notifications and the reliability and poor network conditions improvements that they got from there. Now, you may have seen Jeff Bertoff's talk, or maybe even Aaron Gustafson's talk. They had covered a little bit about PWAs. Maybe you've seen this. Basically, a minimum viable PWA requires that you use HTTPS, you have a web app manifest defined, and you have a service worker. And as you know, there's more to it than that. PWAs are about expanding the already great sites that you guys are building and applications and enhancing their performance, their resilience, and the engagement of those applications. Today, that's what we're going to be talking about. How to build those offline, capable, performant, and re-engaging web applications. We'll first talk about why the web is a first-class platform and why some old web features that were there before were supplanted by new ones that enabled some new scenarios. Specifically, what you're probably here for, service workers, and of course, the other technologies that are involved there, like fetch and caches, and also push notifications for re-engaging those users. So you may have seen a list of PWA principles, as you might have called them. They may have seemed like this or in another form. But basically, we're going to focus on two of those principles, working offline and reliably under poor network conditions and being able to send those push notifications. For the first one, today, if you take the weather app, for instance, in Windows, you'll notice that the app can work offline. It will give you an experience even if you're not connected. In fact, if you look closely underneath the temperature, it's going to tell you that it was last updated at some point in time. And this is what native apps have been doing for a very long time. They will launch to some experience, even if you're not connected. And if you try this on the web, in a browser, for instance, you're going to get this, a very frustrating "you're offline" page. That icon on the right indicates that you're offline. You don't have Wi-Fi. And this problem is not unique to Edge or, obviously other browsers as well have this problem. If you're not connected to the internet, you're not going to get your experience. And then there's the other aspect of sending notifications as well. Today, a native application is able to pop a toast that you can then click and go back to the application so you can re-engage with it. With the web, however, you're left stranded. There is no way to send a notification if the browser is not open or if your web application is not open. So to start, it's important to understand that there were a lot of gaps in the web. And when you compared it to what native apps were capable of doing, it kind of looked like this. So a bunch of contributors and browser vendors took to the W3C, the World Wide Web Consortium, where we standardized web-based technologies and capabilities, and we came up with a way to fill some of these gaps. And as you know, history played its way out, and we created a bunch of different APIs that are web standard along with the different vendors. This was a joint effort. And so we went from something that looked like this to something that looks a little more like this. We're a lot more capable as the web now. We can do a lot more. And to really understand where we are now, I want to take you back in time so you can see what it kind of looked like in 2012. So we're going to go back to 2012 and take a look at something called application cache. And I have these demos. You can access them on aka.ms/swdemo. And we're going to do the first one on app cache. And my computer fell asleep. Give it a sec. OK, so here's a very awesome web application that I built. It's basically a weather app. I've rebuilt some parts of that weather application we saw before. Of course, it's telling me the weather. This is not accurate. As you know, it's pretty warm outside right now. For those of you that only know Celsius, this is below freezing. Yeah. So if I refresh this page, I'm getting that experience there. And if I disconnect from Wi-Fi, which is what I'm going to do right now, and I refresh this page, you'll notice I still get an experience. So I'm still getting something. But you may have noticed when I was connected, I didn't get the updated weather information. In fact, it's telling me that it's still updated as of 10:16 a.m. this morning. So there I am connected again, and it kind of looks like it's busted. So this is how you would have used application cache. You basically had your HTML page that you would then identify your manifest file that's going to tell you what things to cache. And you're going to do that by saying manifest equals appcache.manifest or manifest.appcache. And then you're going to specify the actual manifest itself. The first thing you're going to do is you're going to say cache manifest. And here I have a comment saying when it was last updated. And then I'm going to, under the cache heading, say which resources I want cached. I'm telling app cache, these are the resources that if you make a request, pull them out of the app cache. Don't go to the network. And of course, if we are connected to the internet, for any other request that is not defined in those previous rules, go to the network for those requests. That's what this star wildcard is. And then I can also specify a fallback. For example, if you have an experience that actually requires a network connection, like maybe a contact us page, I can have a fallback experience for that. So it wasn't really quite the silver bullet we were looking for. Jake Archibald, a tech evangelist, had some choice words about application cache. If you're interested in knowing what those words were, feel free to follow that link. And to kind of give you an idea of what those were, you kind of saw it right there, but you basically had to update the manifest file if you wanted to change anything. That's very important. So you notice that comment I had inside of the manifest? I would need to update it maybe just a little bit, and then it would allow it to change. So you also had the different manifest files. If you had them become stale for some reason, if you set a far future caching header, you're basically hosed in the sense that you can't update your experience. So you have to be careful of that as well. The files come from the app cache even if you're online. Did you guys notice how when I refreshed the page, even when I was online, the files, the actual weather data did not update? So that's a problem too. All of the rules inside the app cache are statically defined. There's no form of dynamic caching with app cache. And quite frankly, it's very magical and difficult to debug. The browser is doing a lot of stuff on your behalf as the web developer, and you really can't tell what it's doing. It's not like JavaScript where you can set a breakpoint and then see what's happening. In essence, you have no control. So app cache is useful. It had its time and place. But we can do better than that. So to do that, to give you back control, we have to first look back at exactly what causes the problems in app cache, which is from the very first point where we have the requests happening in the app cache, we have to redefine that. We have to unify that concept. And so we've introduced the concept of fetching. So in a normal web page, you have a bunch of resources that are happening, that are being downloaded. So you have your HTML, your JavaScript, CSS, images, whatever, XHR, XML HTTP requests. And then they normally go to the network if there's no HTTP cache for that item. With this new concept of fetch, instead of going to the network directly, we basically abstracted that concept. So now they go through this fetch layer, this fetch abstraction, that then can go to the network. So there's some interesting side effects because of this, one of which is we can expose these concepts to JavaScript, such as the fetch method, so that you can invoke fetching programmatically, and also the primitives for request and response. So this is what a fetch might look like if you were to write it programmatically. So first, you would make the fetch to weather.json. And then we're going to use, because this is going to return a promise, if you've never used promises before, just know that if you have something that's returning a promise, you can use .then, which will then let you do something asynchronously after the promise has finished. So it's a way of doing asynchronous programming in this sense. And most of these concepts are going to be using promises, so if you're not familiar with them, I do encourage you to read up on them. So from that point, we can check if we can actually get the headers object and then we can see what the content type is. And if in this case it's application/JSON, we're going to get the JSON from that file. And the way that we do that is use the .json helper method, which will help get back the JSON data. For comparison, this is what it would look like if you were to do the same thing in XML HTTP request. So it gets you the same result, sort of, but what you're getting is a lot more code that you have to write, and it doesn't look as pretty as fetch. So back to where we were. You get your requests, your sub-resource requests for all the files. We're going through the fetch pipeline that we've now built. And now, at this point, you're wondering, how do we give that control back to web developers? How do we give it back to you? So you might be thinking of maybe a worker, JavaScript worker type thing that maybe could take that request and do something with it. And in fact, that's what it's going to do. So you may have heard of web workers, but this is even better. This is a service worker. So this is how a service worker works. You have your page, and it usually just goes to the network. It's getting its requests out there and then gets responses back. When a service worker is in play, instead, the service worker gets to intercept that traffic and then return back to the page any of its responses that it wants. So you're probably wondering, this is all well and good, but how is this supported across the different browsers? Do other browsers have service workers? And I'm happy to report that we now all do have this support. As of the April update that came out for Windows, service workers are now on Microsoft Edge and for progressive web apps, for web applications if you're going to use them. So to use the service worker to intercept fetch traffic, you would basically have to write in the service worker a fetch event handler. So we're going to do self.onFetch. You could also do self.addEventListener fetch if you want to do that as well. And then from there, we're going to use event.respondWith, which will give us a special capability to respond back to the page by passing in a promise that either gives us a response object. Remember when we were talking about fetch, the response objects, or we can pass back a response itself. In this case, we're going to do what's called a pass-through. We're just going to do a fetch with that request that we got, and we're going to let that go through. So we're going to see another demo here of what that looks like once we've just set it up to do just that. So here we have that page again. This time it's using a service worker. It's not using app cache. So you can tell that I'm going to refresh this page. Oh, maybe I... Looks like it doesn't like me reconnecting and disconnecting from Wi-Fi. All right. There we go. So by the way, you guys can go to this page, and then you can see all these demos as well, and also explore the code on GitHub if you like. So I'm going to go to that sample page that I was just talking about. So there we are. It's telling me that this is updated as of 3:16 p.m. By the way, this is giving me nonsensical data on purpose so that you can see that something is happening. Obviously, 38 degrees again is not the temperature outside. So what I'm going to do now is I'm going to disconnect it, and I'm going to try this again. And what happened here? Well, if you noticed, we actually didn't really do anything but pass it through to the network. In fact, what we really need to be doing is we need to save those responses so that we can do something with those saved responses and then give it back to the page. Because when I go offline, they're not there. I need to put them somewhere. That's where we introduce the cache APIs. So again, back to that diagram of making the request to the service worker, except this time we'll be going to the caches, using these new cache APIs to go back to the page with something that we've saved. So to give you a bit of a sense of what those caches look like, they're basically a key value storage mechanism, where the key is the request and the value is the response. The request object and the response object, back from what we were talking about fetch. For simplification, you can think of the request as being just the URL and then the actual content of the response for the response. So you're probably wondering, now we've introduced a new concept, a new storage mechanism to the web, cache APIs. What about IndexedDB? You may have heard of that. So a good way to think about this is if you have URL addressable content, like a request and a response pair, put it in the cache API. Anything else, continue to use index database. Put it there. I just want to make a quick side note about quotas in Microsoft Edge. So as you know, depending on the size of your volume on the device that you're on, you're going to have a different set of quotas for both IndexedDB and the caches, the new caches API. And depending on that, you're going to have a different total limit. And on that total limit, you'll also have, per domain, 20% of that total limit. So something to keep in mind as you build your web applications. It is also worth noting that if you have a PWA, something that gets installed to the user's system, to the device, then they won't be subject to these limits. They'll be just like any other application on your system where they can take up the space that they need to. OK, so now we're in business. We can actually save those responses so that we can use them later. All right, so we're going to register that service worker, which is the first step before we even use it. So first we're going to do navigator.serviceworker.register. If I had a nickel for every time I wrote that, just memorize it. Navigator.serviceworker.register, OK? Then we're going to pass in the file that we want to register. It's just a JavaScript file. Here we're calling it sw.js. And then we're going to specify a scope. In this case, we're just going to use the default as the root. It's worth noting that the service worker, where it is in the directory structure, will basically need to be in the same scope that you're going to define. And again, we're using promises here, so if that succeeds, we can do something with that. And if it fails, we can catch that response and say that installation fails. So some quick notes before we move on and talking about what service workers, how to use them and how they work. Some things to keep in mind. They're HTTPS only, so that means your site needs to be hosted on HTTPS for security reasons. You can do it on localhost as well. Browsers will work if you use localhost. You don't get any DOM access inside of a service worker, the same way that you don't have DOM access in a web worker. So if you wanted to do something on your page, you're going to use something like post message from your service worker back to the page so that it could then do something like update the page. If you have app cache specified for a page that also specifies a service worker, the service worker takes precedence. In fact, if you have the service worker, app cache just doesn't work. This might be a way that you would provide that progressive enhancement that you may have been hearing. So if you have a user that doesn't have a service worker enabled browser, they could still take advantage of app cache, which has been there for a while now. The original script, that sw.js, can't be on a content distribution network. You can import scripts from a CDN, but that original script can't be on a CDN itself. It has to be on the same domain. It has to be served from the same domain as your page. It's also important to note that they can be terminated at any time. A service worker is at the mercy of the web browser or the operating system. So for instance, if you have battery or storage pressure and it's trying to do stuff, then they could be terminated the same way that any other process can be terminated. Now, normally this won't affect you, but it's important to keep in mind so that you know that your service worker only has so long to do what it needs to do inside of the events that it's going to handle. And I'll talk a little more about that in a bit. Only async requests are allowed in a service worker. So there's nothing like a synchronous XHR going on over here, okay? Only fetches, which are asynchronous by nature. And you can't use local storage either. You have to use IndexedDB, which is also asynchronous, and the caches API. They execute separately from the page. So if you have a page that normally executes JavaScript, you also have a service worker that's executing separately. And this is important to note because their execution contexts are not tied. You don't get the same globals, for instance, from your page as you do on your service worker, the same way that you don't get that for a web worker. And we saw a little bit about that scope earlier. It's important to note that the scope to service worker mapping is one-to-one, meaning that if you have a service worker that is going to be registered on the same scope again, it will update that service worker so that you can get the new version for that service worker. All right, so now that we kind of got through some of the basics, we're going to go through the life cycle of a service worker, which is important to know. Because you may be wondering, okay, you have this service worker, how do I maintain it, how do I update it? Well, we got to start with how exactly it goes through its life cycle. So the first step of its life cycle is that it goes through the installing phase. This is the beginning of everything. This is when the registration happens and where we set everything up for the service worker. And I'm going to show you what you do there in a bit. Then we go to the installed phase. So it goes from installing to installed. At this point, the setup is complete, and we're waiting for anything that is using the service worker, where using means that if a page is trying to use a service worker to get responses from, it's going to wait for all of those pages to be closed, for instance, all those tabs. So if you had like 3 tabs that were using one service worker, those 3 tabs would have to be closed before you can actually be installed. From that point, you go to the activating phase. So at this point, no clients are controlled. So you've killed off all those browser tabs, for instance, or the app, if it's an app. And what we might want to do here is clean up any older versions of that service worker. For instance, our caches. I'm going to show you how to do that as well. And then we go to the activated phase. At this point, the service worker can fulfill its destiny and handle those fetch events that we've been talking about so that it can respond back to the page when a request is made. And then finally, it becomes redundant. This is when the service worker may be replaced by another because it's being updated. So starting with the first step, to install, the first thing that's going to happen is an event will be fired in the service worker. and we were going to handle that event. It is the onInstall event. And again, you can use add event listener as well. So in this onInstall event, we are going to use event.waitUntil. Event.waitUntil says we're going to pass a promise into you, and when this promise finishes, resolves, we're okay with letting the service worker go away. So we're going to use the caches API by using caches.open, and caches are a global variable in both the window object, so on your main page, and also the service worker as well. We're going to specify a name for that cache that we're going to open. Here we're calling it assets v1. And then when that cache is opened, we will then use a helper method, cache.addAll, and we're going to have a list of things we want to prime the cache with. These are all the things that we think we're going to need as part of the shell of our application, for instance. So these are resources that if they don't get installed, we're not going to register the service worker. It's important that these files get installed so that we can at least have some base experience for our application. So that addAll is basically implicitly doing those fetches for those items and then putting them into the cache. It'll help us do that. It's a simple way of doing that. So now that we've done that, let's take a look back at our demo here. So what we're going to do here is we're going to check out F12. We're going to see how this service worker looks. Because obviously you can't really see it, but if you open up F12, there's a way for us to see that something's going on. The first thing you're going to see is that the page, or F12, has detected that we have a service worker for this page. And this is important to note because if you have any network traffic happening on this page, the network traffic that's being serviced by the service worker will actually happen in the service worker itself. So what I mean by that is if we go to the debugger tab and go to service workers, we'll see our domain there. We have a bunch of service workers here installed for each of the demos I have, but we're gonna scoot on over to the /basic, which is what this demo is. I'm going to click on the inspect link, which will then open up a separate instance of F12. And in this instance of F12, I'm able to see the JavaScript that I had written before. And what I can also do is I can go to the caches and inspect the caches as well. So under assets v1, I could see a bunch of resources here that are cached. And what I was trying to say before about the network traffic, if any network traffic happens in the service worker, it's going to show up in the network tab of the F12 instance debugging that service worker. So you won't see it here, and that's what that warning is about, FYI. Okay, so now we've gone over to the installed phase. And once those clients have been closed off, we've closed off all those tabs, we're going to move to the activating phase. This is going to now signal the service worker with another event, the onActivate event. Again, self.onActivate, it's a different event here. And in the service worker, we're going to have a list of caches that we want to keep. So we're going to define a keep list. Here we want to keep our v1 caches. So even though we're upgrading, for instance, our service worker, this would be the opportunity for us to clean up those older caches if we needed to. Again, event.waitUntil, so we're going to wait until that happens. And what we're going to wait until is we're going to use caches.keys to get all of the different caches we have. And then we're going to permute through them. And when we permute through them, we're going to check if any of those things are inside of the keep list. And if they are, we don't delete them. And if they aren't, we delete them. By the way, on the top right corner, I have git.io links if you want to see these samples so that you can consume them later. So now we've gone to the activated step. So again, the service worker can now that it's activated, fulfill its destiny to handle those fetch requests. So back to that example where we have self.onFetch, we are going to, instead of just going to the network and doing a pass-through, we are going to do caches.match, where we're going to ask for the request that we just got from the caches. And if it's there, we'll return that back to the page. And so the page now has, or it's loading, what we just put into the cache during our install step. If we don't have something in the cache for that specific resource, we're going to instead just fetch it from the network as sort of a fallback. And if we don't even have the network, if that fetch fails, using the .cache for the promise, we're going to return something we do know is in the cache, that file that we cached as part of the install step, the fallback.html. So again, at the final step, now you are at the redundant state if a new service worker is being registered to take its place. So we're going to switch back to another demo now that we've done all that fancy stuff and see what that looks like. So here we are, we're online, we're loading it up. Looks all fine and dandy. All right, let's disconnect from the network, see what happens. Oh, please connect to the internet and retry. So we could do better than this then. And in fact, we will. So something we weren't able to do before with the caches, with app cache, was being able to cache dynamically. This time, we're going to cache dynamically. So what we're going to do is, instead of doing that fallback step inside of our onFetch handler, we're going to instead open up a new cache and call it dynamic, and then put that item that we just got from the fetch into the cache, into that new dynamic cache. So we're dynamically caching if it's not already in the cache. And then we also want to still respond back to the page with what we just got from the fetch. So we're going to return the response, but we're also going to have to clone it because that response just got consumed by the put operation for the caches. So it's important to note that you'd have to do that. So now, if we switch back to the demo with this new improvements, we're able to get an offline experience where it shows me the last known state. So that's better. And of course, if I'm going to go online again, so I'm caching dynamically, but I haven't accounted for the fact that if I'm online, I want to get new data. So back to the drawing board. All right. So we can do better than this. And I'm going to show you what that looks like. So what we're basically going to do, as you would expect, if you're online, show something. And if you're offline, don't. I'm going to spare you from that demo. I'm sure you guys know what that looks like. So how do we do that? Going back to our onFetch handler, we're going to have two different paths. The first path is going to check if we're making the request for the weather.json. If so, we're going to respond with a fetch and cache. And the fetch and cache is just doing what we did before. I just encapsulated as a method here. So just opening up that dynamic cache and then putting it into, and then doing the fetch and then putting it into that cache and then responding back from that request. Otherwise, we're going to do what we were doing before. So on the weather.json file, we're going to just do a fetch and cache. We're not going to do a from cache first. And then, of course, on the page itself, on index.html, we're going to request that weather.json and do something special here too. So when that request comes in, we're going to get the JSON like we were before, and then we're going to update that page with the JSON. And then if it fails, well then we can just get the thing from the cache. so that if you're not connected to the network, you're still loading it from the cache. And we're going to do the same thing there. So once we get it from the cache, we want to get the JSON and then update the page with that JSON. And then if all else fails, if we don't have it in cache and we don't have a network connection, well, we got nothing. You may want to show a different experience for that. But we can do even better than that. So what we'd really like to do is offer an experience where when you're connected, it's going to show that for a brief second, I'm going to show you that again. It's going to show the offline experience where it's showing it from the cache. I'm going to show it again. And then it's going to load immediately freshly from the network. Again, this is sending me nonsensical data to show you that it's updating from the network. So this is what we'd like to do. And if I turned off the network here, it would just load that offline experience, and then that's it. So now we've gotten to a state where we're behaving like that weather app was at the beginning. And so you're wondering how we do this. So let's take a look. So what we're going to do is we're going to race the network with the caches. First, we're going to set a global network done, set it to false, because it's not done yet. We haven't done it yet. We're going to then assign a network request variable to a fetch request for that weather.json. And then again, we're going to get the JSON from it. And we're going to set here the network done equals true. And then we're going to update the page. At the same time, we're also going to make a request for the cache for that same file. And if we get it, again, we get the JSON from it. And then only if the network isn't already done will we update the page with the cache, because it's possible in some circumstances that the network may be faster than the cache, in which case you don't want the cache data to supplant the network, the fresh network data. And if we don't have anything in the cache, we're going to do a .catch, and then we're just going to return that network request, the variable that we set before, for the fetch, in which case the network is basically our last hope. It better have something. And if we still have nothing because the network is not there and we haven't cached it yet, then we would have a fallback experience because we have nothing. So far, we've really been talking about two different types of events. Lifetime, where we have the install and the activate, and the functional, the fetch event. And we spent a lot of time talking about this fetch event and talking about working offline and reliably under poor network conditions. But service workers are a web app model that enables event-driven JavaScript to run independent of web pages. This is a very powerful mechanism that could enable other experiences. Namely, if you recall, that push notification scenario we were talking about before. So I'm going to show you what this might look like. So switching on over here, I'm going to go to my push demo. It's going to ask me if I want to show a push. I'm going to say yes. I'm going to give it a second. And then I get a weather advisory notification on the bottom right here. In this case, it's just basically loading it up and then showing it. And it gets integrated into the Action Center on Windows, so you get to see it here. And if I don't act on it, I can act on it later and click it, and it will do what it's supposed to do. I can dismiss it and do the other nifty things I can on Windows, like turning it off, for instance. So we've also built, as part of this talk, a demo, a push tutorial that you can follow if you want to understand more about how webpush works. I'm going to show you that demo, that tutorial right now. So it's aka.ms/webpush. Whoops. So basically, it'll walk you through the different steps on how to set up the server and the client side in a nifty little way here. I'm going to scroll down. So this is just kind of giving you a sense of what this looks like. I encourage you to go to this URL and learn more if you want to learn more. We're going to walk through some of the basic concepts here, but this is a fully working demo that you can also fork on GitHub to understand the concepts that we're going to talk about a little bit better. And so to kind of give you a sense of how this works, if I click Initiate Push here, it's going to show me a push message that I can then click, and then it would reopen the page. Of course, in this case, I'm already engaged with the page, so it's going to just focus the page. So let's talk a little bit about how push works. So you have your page, and you have the service worker. And of course, the first step is to register that service worker, like we've been doing. But so far, we've only been talking about the client side. Let's bring in the server side as well. So the first thing we're going to need to do is talk to our application server and get what's called a public key. We're going to need this to subscribe for our push message so that we can set up our push message channel to get updates from our server. The next step is we're going to subscribe for the push. And that's going to talk to the push services server. And in Edge's case, Microsoft Edge's case, it's WNS, the Windows Notification Service. There's FCM for Chrome, and there's MCS for Firefox. So they're all different, but we're going to do it in a standards-based way that will work across all the different platforms. So we're going to make that request to subscribe from the push server. We're going to get that subscription data, and we're going to save it on the cloud. We're going to save it on our application server. The reason for this is because at some other point in time, we are then going to get that subscription information, which is going to have, for instance, the endpoint URL that will tell us exactly where to send a message to, which will then notify the push service, again, using that endpoint URL, and then that push service will know how to talk back to our client device, and notify that service worker that we got a push message. And again, once that service worker gets that message, we'll be able to show a notification. And when that notification is shown, we can click it, and then it could do something like show the page. So we're going to walk through the different files that would be involved in making this. We're going to be using a Node.js server to build this, but you can build it with other types of servers. I'm using it because I'm going to be using the webpush library, which will help us kind of abstract away all of the encryption and cryptography logic. So the first file, the index.html, which is our page, it's going to be handling the registering of the service worker and creating the push subscription. And then the service worker is going to handle the push event and the notification click event. So when the notification actually gets clicked, it's going to be handling that as well. And then we're going to have our serve.js, which will actually handle the server logic. It'll be routing all the requests. So the API endpoints that we're going to be using will be routed through that. And then we're going to have a database file that's basically going to connect to some backend database, for instance, MongoDB, which is what we're going to be using here. And then it's also going to create the object schema for what the data we're going to store. I'm going to show you how that looks as well. And we're going to have a notify.js. Again, this is all server-side. This is going to notify the users. It's going to send a push at some other specified point in time. So from the client side, we're going to be taking advantage of service workers, the push API, and the notifications API. From the server side, we're going to be using something called VAPID, the Voluntary Application Server Identification. It's kind of a mouthful. All you need to know is that it's going to allow our client to interface with the push services server so that it will know who it's talking to. So it's a contract, sort of a handshake. You're going to see what that looks like in a bit. And we're also going to be dealing with message encryption. And again, we're going to be using the webpush library that's available via Node so that we don't have to deal with the actual encryption logic. We're just going to be using helper methods that are going to do that for us. But it's worth noting that there are two types of content encoding types, AES GCM and AES 128 GCM. So to set up our server, we're going to be using Express. If you've never used Node, it's just a minimalist server that we can use. And so we're going to set that up, require Express, and we're going to use the body parser so that we can get the JSON from any of the responses we get. We're going to include that DB file that we were talking about before, and then we're going to instantiate the Express server as well. And then we're going to tell Express to use some directory and serve them statically, and we're also going to tell body parser to use JSON. Now, these details are not that important. It's just kind of getting us set up for the server, but it's important to know how exactly we're going to do this so that it's not magical. It's not smoke and mirrors. There's something happening here that is that I'm hoping to demystify. And then we're going to tell it to listen to the port of our choosing. I'm going to be using 4000. And then if you run this in, for instance, Visual Studio Code, you'll be able to see that our server runs, and it's listening on the port that we specify. And at this point, you really haven't done much. You just kind of started up a server. So this is where it gets more interesting. We're going to include that webpush library that I was talking about as part of the first step. Then we're going to specify two keys, a public and a private key. This is about that Vapid thing I was talking about before, so that we can interface with the push services server to let it know what the client, who the client is, so that it can identify itself to the push services server. In this case, you could actually generate these using a helper method, using the webpush library. It's just webpush.generate vapid keys, and it will give you those keys that you can then put into global variables up at the top. You don't have to change them once you've set them up. Then we're going to configure the webpush, the webpush library by setting the vapid details. We're going to specify an email address, and then we're going to specify the public and the private key. So we're going to move on to the database file to actually save the subscription data. And I'm not going to bore you with all the details of setting this up. We're just going to focus on the schema, the data that we're actually interested in storing. What we're interested in storing is the endpoint URL. So again, the URL that we're going to talk to from the push services server so that we can message the client, and the keys, the encryption material that we're going to use. So this is what it would look like. I'm using here RoboMongo, which lets us introspect all the details of the database. And you can see it's JSON formatted exactly as the schema I was showing. This is sort of how it would look if you had an endpoint and the keys populated inside of a database. So let's go through our workflow now that we've set up the server. So the first thing we're going to do is we're going to register the service worker. So that's from index.html. It's going to register serviceworker.js. First thing here, obviously, we've done this before. Do you guys remember what the key magical thing is? Navigator.serviceworker.register. And then we're going to use a special property on there, navigator.serviceworker.ready, which will tell us when the service worker has something that is activated that we can use to set up the push. So when it's ready, we're going to, using the registration of the service worker, get its push manager, and then call get subscription to see if we already have a subscription. Because if we do, we're just going to give that subscription back, and it's OK. We've already subscribed. In fact, you may want to have something a little more robust, because some of these subscriptions can time out. They have, for instance, a 30-day time limit. In this example, what I'm doing is I'm saying in the last 5 days of the subscription, I'm going to renew it by first unsubscribing and then resubscribing. So we're going to get the public key as the second step. To do that, going back to our example here, we are going to call get public key. So if we already had a subscription, we're just going to return that. But if we don't, we're going to need to get the public key. And all get public key is doing is it's making a fetch to some endpoint URL we specified. Nothing magical there. And then it'll get the JSON from there. And then it will call this method, URL base64 encrypt convert. For this, you will need to do on Chrome, but you won't need to do it on Microsoft Edge. The value you specify as part of the application server key will need to be in this format. So from the server side, all you're doing is, for specifying that API/key, all you're doing is you're responding back with that vapid public key we set up as a global. That's it. So it's nothing complicated in that sense. And then we're going to subscribe for push. So again, this is going to interface with different types of push subscription services, depending on whether or not, depending if you're on Edge or Firefox or Chrome. And that will happen here. So we're going to do reg.pushmanager.subscribe, and we're going to specify user visible only true, and the application server key, that public key we just received. We're going to put that in there. And it's important that we specify user visible only true because it's creating a contract with the browser that we intend to show something when a push message arrives at the client. It could be the case that you may not want to show something like, you're getting push and then you want to do something like Bitcoin mining. Well, that wouldn't be possible if you specify this. In fact, we won't let you register unless you specify true here. So you have to show for every push that comes to the client, it has to show a notification so that the user knows that something is potentially happening in the background. I'm sorry if I killed any of your hopes and dreams of Bitcoin mining.
So you can't set it to false? It's always true?
Yeah, you have to set it to true. On Firefox, you can set it to false, but that's another can of worms. So when you call subscribe, what will happen is you're going to get that prompt. At this point, you're going to get that prompt for permission if it's not already granted. In this case, if the user says yes, we will then, the browser or the engine, the platform that you're on, will issue a request. This is just a plain old HTTP request. If you've ever seen one of these, it's very simple. It's just a post request to this endpoint that will then give us back the information about the subscription that we can then use. Again, trying to demystify this here for you. You're not going to see this happening in the browser, but this is what it's basically doing. So at that point, on our application server, so the code we own, we're going to save the subscription data. Okay? So again, from that registration of the service worker and the push, the last thing we're going to do is once we have a subscription, we're going to go ahead and save that. We're going to pass it up to the server. And what save subscription is doing is just doing a fetch. It's just telling the server, hey, here's the subscription data. Go ahead and save that inside the database. And on the server side, we're going to handle that. So what we're going to do is app.post and specify the API for subscribe, which is going to save this data. We're just going to create a new subscription object. And again, I don't want you to get bogged down with the details here. All it's really doing is just saving it into our database. So you can interpret this for any different type of database you're using here. And then we're going to save that to the database. And then we're going to tell the page that it succeeded. We're all good. So using, again, RoboMongo to introspect the database, we can see now that things are showing up inside of our database. And again, we have the endpoint URL here. We have the keys, the encryption material. This is needed for sending push updates for later. But really, you don't really need to worry about exactly what these are doing. You just have to save them so that the web push library, when you pass it to it, can do the right thing when it needs to send the push message. So here comes that other point in time where we're going to retrieve that data from the database. And to do that, we're simply going to just use a method that will enumerate all of the items in our database. And of course, at that point, once we've enumerated them, we've gotten it out of the database, we want to notify the push services server that we want to send a push message to the client. So to do that, we're going to call webpush.sendNotification. Again, this is a helper method, and I'm going to demystify this for you. It's kind of ugly, but this is what it does. It basically sends a request to the web push or to the push services server. Again, a simple HTTP request asking it to give us back details about whether or not the push was sent. But here, it's just issuing a request. Please send this data. And at the bottom, it's the encrypted push message there that we want to send to the client. So if it fails, so if the server comes back to us with a 410, what that means is the subscription is no longer valid. So maybe the person, the client, for instance, decided they no longer want to receive pushes from you. In this case, you want to see that it got a 410, and you may want to actually remove it from your database so you don't keep trying to push to it, because then it becomes wasteful. So here, we're going to remove it from our database. In case you're interested, you can emulate the push event in a service worker using F12. So in that same panel that I showed you before where the service worker overview page was, you can click push, and it will send a push. It's just a faked out push message to your service worker so you can test out the push event handler in your service worker, which is what we're going to be talking about now. So now we notify the client's service worker. So here's another event for the service worker on push. All right. We're going to get the payload, and we're going to grab out the text, the data from that payload. So this is that encrypted message we got. From here, we're going to wait until we show a notification. So how do we do that? We basically call registration.showNotification. We're going to pass in a title, and we're going to pass in a payload, which is the message we got from the push, and we're going to give it an icon as well so that it could show something. So we're going to do a little bit of an interactive demo here where you guys are going to send me a push to my device. If you guys want to either open that up or one second, I'm going to switch over to the other one. All right, I'm going to keep it. So you guys are sending messages. Look at that. They're all piling up. All right, guys, keep it coming. So all this is really doing, by the way, is you're loading a page that is making a call to to the server, and it's telling it to send a push to the push services server. All right? So it completes that loop. And then it comes back to my client here. Wow, holy cow, guys, 21. OK, so that means that we're now able to, on the client device, we're getting yes, I'm annoyed. Thank you. So that's what I'm about to show you. Very, very nice. So what I can do here is, because you guys, come on. I can turn it off, or I can clear the permission, and then I effectively disable you guys from sending me more pushes. But you can see here, these are all the pushes. They all got stacked here into my Action Center. And they all get grouped under that same domain. So we've tried really hard here to integrate with the Action Center so it feels more like a native application. So I'm going to close this and show you what it looks like when you actually click it, because that's what we're not going to talk about next. So I'm going to click on this, and what it's going to do, because you can tell that Edge is not open down there, it's going to open Edge, and it's going to navigate me back to the demo. So this is a good way. You can specify where you want it to go, but this is a good way to repatriate your users back to the page that you intended them to go to. So thanks, guys. So now we're going to show the page, and you just saw how that worked. I'm going to show you how to do it. So we're going to handle the notification click event. What we're doing here is we're saying, so on notification click, and then we're going to first close the notification. So we're going to tell the notification to go away. And then we're going to use clients.matchAll. And we're only interested in the clients that are Windows, because you can have other clients like iframes, for instance. And we don't care if they're controlled by this service worker. Remember, controlled means that it's servicing its requests. We want all of the service workers, or sorry, all the clients that are under the same domain as the service worker. In this way, we can then enumerate through them and choose a client, if one exists, to focus on. A more robust implementation might actually check for those clients and see if there's not just the first one, but see which one would be a better match. Again, these examples are part of that webpush tutorial demo, so if you wanted to get more context on that, I advise you to go check it out. It's on the top right corner of that slide. And then, if we don't have any clients, so if none of those are open in the case that I just showed you, we're going to open a window so that we have something that will actually be shown. So here we're just doing clients.openWindow, and we're specifying a place for it to go to. And so here we go back to our app, or whatever it may be. So as a bonus, although on-push subscription change is not implemented by the various browsers, we are looking to implement this, especially considering that Windows Notification Service does have that 30-day period where it will get expired. So if you like, you could implement this method to future-proof you. Here's what you might want to do here. So listen for the on-push subscription change event. This is when, for instance, you're at that end of that 30-day period and we attempt to resubscribe you. We're going to wait until both of these promises are finished. I'm going to go through the first promise first. The first promise checks if the old subscription is specified, and if it is, let the server know to delete it. Okay? Otherwise, just resolve the promise, and it's fine. The second promise, if a new subscription is specified, just resolve it with that. Otherwise, we're going to just subscribe for a new push. And that's that part. And we're then going to need to tell the server the new subscription info so we can save it. So far, we've talked about the different lifetime events and these new functional events like push and notification click. But again, a service worker can do way more than this. And we can expand on the possibilities here. You may have heard of something called background sync or periodic sync, for instance, where, for instance, let's say you had a news application or an email application that you wanted to sync information at a regular interval, and the person didn't have a connection at a certain point in time later, but they were able to get that information that was last synced. So these are the new kinds of capabilities that we're looking at in the standards bodies, like the W3C, for instance, to try to come up with ways to enable these new kinds of scenarios using service workers, which, again, is a new web app model that enables these event-driven kinds of capabilities. So the web is a first-class platform. We are moving in a direction where we are going to continue enabling more and more capabilities that helps you as web developers or you as developers to have one more option to building your applications using the web. We've learned about new features that make these new capabilities possible, like service workers and push notifications. I encourage you to try these features out today using the latest Windows update that came out in April. Please install it. Please try it out. Check out the demos. Here are the demo links again if you missed them. You can reach out to us at Twitter at MSEdgeDev. You can link to me at GitHub if you like. And please, guys, if you guys have a moment, please do the evaluation. I'd really love to get some feedback here. So yeah, if you guys have any other questions, I'm going to stick around for, I guess, another 12 minutes. So please. I'll put that slide back up.